Hello, my name is Alejandra Recio-Blanco and I'm astrophysicist at the Côte d'Azur Observatory in Nice in the south of France. For the Gaia space mission, I am responsible of determining what the stars are made of. To this purpose, I coordinate a team of about 15 researchers and engineers, and I started to work for Gaia in 2004, well before the satellite was launched. I will now briefly explain you how we have achieved our goal. The light of a star, when it passes through a prism, produces a band of rainbow colors that is called the spectrum. On the spectrum, we see a series of black bands. Each of these bands characterizes a chemical element present in the star's atmosphere, since the atoms absorb certain colors of the light emitted by the star. These black bands tell us what the star is made of, what its chemical composition is. Therefore, they are a kind of DNA of the star, which is preserved during its life. Gaia's RVS instrument scatters the light like a prism. In this animation that you see, now playing, we see the spectra of different stars, and more particularly, we see the amount of light as a function of wavelength, or if you prefer, the color. The dark bands of the spectrum are at the wavelengths or colors for which the amount of light is lower, as for instance here in the 3 absorption lines of calcium. We have identified the chemical elements responsible for each dark band in the RVS spectrum, and as you can see in this animation, we have deduced the chemical composition of 5.5 million stars. Stars form from clouds of gas and dust. They shine thanks to nuclear fusion reactions and, like alchemists, make new chemical elements. At the end of their lives, these new elements are returned to the gas and interstellar dust, and a new generation of stars is formed. As a consequence, each stellar generation enriches the gas from which the next generation is formed. Astrophysicists call metals all the elements that are produced by the stars, that is, all the chemical elements that exist apart from hydrogen and helium. In the animation that I'm going to show you now, we have used a color code that indicates the star's chemical composition. If the metal abundance of the star is low, then the chemical composition is more primitive and the star will appear blue. If the star is rich in metal, then its chemical composition is more recent and it will appear red. Following this code, the chemical composition of our Sun will appear in orange. So, in this video, you see the results of our Gaia D3 analysis. We see that the sky is full of diversity, and our galaxy is a beautiful melting pot of stars. This diversity is extremely important because it tells us the story of our galaxy formation. It reveals the processes of migration and accretion of stars from external galaxies. It clearly shows that our Sun and we all belong to an ever-changing system formed thanks to the assembly of stars and gas of different origins.